part of the variation are unobservable. Part of the variations are unobservables. And what matters for causality is that the unobservables shouldn't be correlated with your explanatory variables. So you don't want your explanatory variable to capture other variation that could be explaining your dependent variables. So one example is when you have earnings on the left-hand side and education on the right-hand side. The unobservables are capturing all the factors that could explain earning that's apart from education. And as you can imagine, as long as there are some factors you believe unobserved are correlated with education, your causal judgment between education and earning is refuted. And then you can raise all these sorts of variables such as family background, IQ, motivation, and or other cognitive ability. So all these factors, that basically why we emphasize on causality is because causal relationship is a relationship we should focus on for policy evaluation. The purpose of empirical test is to give you some foundation for policy design. What you need to tell yourself is, if I change something, if I change the X variable, if I change the education system, would it benefit my treated residents by increasing their wage? In our example, what we care about is a lot of environmental variables or pollution, related explanatory variables. We care about how it affects your outcome of interest, like in this specific example that I just listed here. You care about whether or not reducing the concentration of NOx, reducing the emissions of NOx could benefit surrounding neighborhoods in terms of housing prices. Would it pay off? Would it pay off to cut emissions down in terms of raising nearby housing value? So what you really care about is this causal relationship. If the relationship is only correlation but not causal, then what we can say is that changing NOx concentration, if basically the correlation between NOx concentration and housing price could be explained by unobservable variables. Unless you change the unobservable variables, you can't you can't achieve your intended purpose. So we talked about a few methods for tightening up empirical causal relationship. There are several reasons why correlation doesn't imply causation. Reverse causality, augmented variables, selection bias, measurement errors. All of these are pretty straightforward. So we talked about experimental methods, but in real life, especially a specific problem we are studying, it's almost impossible to rely on experimental evidence. Obviously, there are experiments done on, especially on improving the management of the environmental regulation system. But to test more fundamental relationships, such as between pollution and health, we have to rely on naturally generated variations in pollution level and outcomes. So one specific method that we've been talking about is the difference in differences method. So can you still recall what this method is about? So the thing about difference in sometimes we call it DID, difference in differences, is that if you can observe both your X and Y's repeatedly, so suppose you have a panel data where you observe the medical records or health data of residents in several cities every year, and you are able to observe changes in pollution outcome every year. What we could do is we could use the change, we could look at how the change in pollution outcome, how the change in health outcome respond to changes in pollution. So the benefit of this is that we can isolate all the time invariant factors that could be causing all our endogeneity problems. So imagine the factors that you think creates correlation between unobservables and pollution per se. They are time invariant, such as location to a road or proximity to an industrial factory, or basically how rich this city is, or the health system of the city. You can imagine if a city has higher GDP per capita, it's richer. It might be more polluted because of the industrial output, but the city being richer could also afford basically better health services for its residents, or its residents are richer, they naturally enjoy better health. So we can isolate these factors if we can observe events around which there are sudden changes in pollution level, but hopefully not in other variables. And we can then observe how this sudden change in pollution level leads to corresponding change in health level, which is hopefully not related to all the other factors we care about. Does that make sense? The specific difference in differences, as opposed to first difference. So difference in differences is the second the difference between two differences. So why we don't just look at first difference, we could look at the change in Beijing. Suppose Beijing is a city that experienced a sudden shock in pollution level as a result of the Olympics. We can just compare the outcome of Beijing post-Olympic to kind of the Olympic year, as well as basically 2009 Beijing health outcome minus 2008 Beijing health outcome, regressing on 2009 pollution in Beijing, 2008 pollution level in Beijing. But one concern is that since we're exploiting the time variation, time series changes in one city only, there could be other factors that's basically time correlate with time. How could you rule out that the different health outcomes in 2008 versus 2009, 2007, when there were no shocks to the pollution level as a result of Olympics? But people could just push back by saying that there are other things happening in 2008. Such as the financial crisis. How could you say that the change in health outcome is not the response to other things such as the financial crisis? So the way people improve this difference outcome is to add another source of difference by using other cities as controls, the cities that haven't experienced change in pollution as a result of the Olympics as control group, and basically look at Beijing 2007, 2009 minus Beijing 2008. Also the other way, Beijing 2008 minus Beijing 2007, minus another city such as Shanghai 2008 minus Shanghai 2007. The idea is that suppose financial crisis has had the same effects or whatever macroeconomic shocks, the time variation, the fundamental difference between 2008 and 2009, whatever that is, they supposed to have the same effects on Beijing and Shanghai. We can difference that out. We can basically take the effect of those factors out using the pre-post difference in Shanghai. Does it make sense? So this is a graphical presentation. I think basically the goal of using a second difference is to single out or isolate out the time variation. The assumption would be the variation in time, whatever reasons you believe, that confound you about changes in health outcomes across years should apply to Beijing and to Shanghai similarly. And the rest difference between the change in health outcome in Beijing and changing health outcome in Shanghai could be attributable to pollution. And we know that the changes in pollution is sort of driven by Olympics. This was some kind of illustration on the effectiveness of environmental regulation around Olympics on PM10 concentration. So as you can see, what the figure was trying to show, I think, is that for the treated city, you can see the treated cities were consistently more polluted than control cities in the pre-sample, but their difference pretty much disappeared after serious regulations have been put in place due to Olympics. And you can see basically these are comprehensive regulations. So the regulation is were kind of more relaxed for the bigger window, but for the kind of shorter, the really narrow window, we had temporary, very strict regulation. And you can see the gap pretty much closed completely. Well, in the pre-comprehensive regulation period, there still existed some gap where the treated city were more polluted. And for years, without any regulations, the gaps were largest. So that's what the figure was trying to tell us. So a lot of you were asking how these things were going to be tested. Of course, I will try to provide examples to you at some point, and you will be seeing homeworks. But a lot of times, I will be trying to present some empirical work or summary of empirical work, showing you maybe some figures from papers we've been discussed in the class. And I would let you just tell me how do you interpret this figure. So similarly, what we're interested in, so the first check was that Olympics proved to be effective, that the advance of Olympics helped Beijing to have its pollution under control. And next, we were interested to see basically whether or not during the Olympic years, especially during the Olympic months, we had less occurrence of pollution-related diseases. So I think this figure was trying to show the difference in mortality between control city and cheated city. So the difference defined as cheated minus control, so how much more or how much less were Beijing residents more likely to die because of several reasons. So CVR or cardiovascular respiratory. So we sort of believe these types of diseases are more related to pollution, and non-CVR this is cancer injury. So as you can see, the mortality rate, because the CVR mortality rate difference out between treated and controlled cities lied consistently below basically in 2008 lies consistently below the same sort of treated control difference in 2006 and 2010. So it basically was showing that Beijing residents in general were less likely to die from CVR diseases. As you can see, this is it's almost, the average is probably almost zero. It's minus 0.2 to 2.2. So on average, Beijing residents were slightly less likely to die from CVR related diseases than people from other cities in 2006 and 2010. But in 2008, they were significantly less likely to die from these diseases. But you can see basically if you look at non-CVR diseases, the Beijing residents were, the difference were kind of ignorable. So does it convince you that the second difference variation in CVR mortality is most likely driven by pollution reduction in Beijing, but not pollution reduction in other cities? So what's your evaluation of this method? Does it convince you? So sometimes I might ask you to provide a critical review or critical suggestion comments on these papers. So here, the purpose of this paper is to tie pollution closely to health outcomes, especially in this case, the measure of health outcome is CVR mortality, heart disease, asthma, these all sorts of diseases. So can you think of a reason that their results are probably capturing other factors other than the pure relationship between pollution and health?
I have one question about the ordinate. I don't know. It's -1. I don't read properly the numbers. 2, -2, -6, -1. I don't understand properly the numbers in the ordinate.
I think this is -0.6, -0.2. So basically, if you look at this one, probably it's just showing that in the April of 2008, the difference between mortality rate in Beijing in treated city and controlled cities were -0.17. Sorry, -0.17. So 17% less likely to die. In the treated city, their residents were 70% less likely to die from CVR diseases than in the controlled city. While in general, in the other years, they were probably equally likely to die from CVR mortality.
So 20% in the 2008.
So the information that you should be taking away is that in 2008, in 2008, the treated cities, like most notably Beijing, CVR mortality was comparatively lower compared to the same gap in other years. So in other years, Beijing residents were not less likely to die from CVR, but in 2008, then the same group of control city, but in 2008, they were significantly less likely to die from CVR. And the assumption would just be that the other factors that might explain why Beijing residents were more or less likely to die from CVR compared to other cities were not changing rapidly between 2008 and 2010 and 2006. But the only thing that changed rapidly during this period correlated with health was pollution. So that's the belief that the authors were trying to claim, trying to make you to trust his results, basically.
Well, I could say that the cancer mortality, it takes much longer time. It's not so much related only to the pollution as well. Injuries are not related, I suppose.
Yes, that's what they were trying to claim, that the effects only show up in CVR, but not in injury and cancer, because ideally you don't expect injury or cancer to be related to pollution. So you were trying to say that, trying to use this as a placebo test. A placebo test is a test where you shouldn't find results if your story or if your methods were true, and if you didn't find any results, any positive effects in the end, it kind of gave you a little bit more trust in your methods.
Could you also argue that people were maybe exercising more from being inspired by the Olympics? Because I'm sure there was marketing probably going on 3-4 years before 2008, and then come closer to the time, all of a sudden the air is a bit clearer. You see more beauty in nature because there's less pollution, so people start exercising more. I don't know, just thought I'd throw that out there.
yes, indeed. Your critique is a valid one. So if you believe that Olympics make basically cheated city residents in cheated city more likely to exercise than residents in control cities, was likely that it could explain part of the effects. But of course, the authors could push back saying that the effect of exercise is more long term. Here, as you can see, they were just looking at very short term responses of health to pollution. So as a result, they can't claim that we are capturing the full health effects. They were just trying, and they're looking at mortality. So it's a mortality health effects. It's very extreme type of health effects that actually make people die, right? So basically, you can imagine these were cases where pollution made someone with pre-existing heart conditions more likely to have a heart attack and die from that. So these were some part of the health effects, but not the full health effects. So another method so we talked about differences. And another method about dealing with the endogeneity problem is what we call the instrumental variable method. An instrumental variable method is that sometimes we can find instrumental variables, which was defined as a variable that is related to x, but otherwise independent from y. So if you can find a factor, so if you want to explain the effect between x and y, and you can find a third factor that only affects y through affecting x, we can construct a method to kind of parceling out or reviewing the true causal impacts between x and y. Even if you believe x1, that there are loads of other factors that could explain the relationship of x and y. There are all loads of endogeneity bias. As long as you can find this that's only that in your mind was only supposed to affect y through affecting x, we are able to isolate. You can imagine x has good variation and bad variation. The bad variations were correlated with your u variable, your unobservables. So ideally, if we can help to use some kind of filter to filter out the good variation in x that's more exogenous, we were able to kind of pin down the good variations and explain the part of y that could be causally attributable to changes in x. I know it's very abstract, but an idea for some examples for instrumental variable is that if you want to, suppose your idea is to test how the conflicts in Africa, how the civil war or local conflicts in Africa could be attributable to economic reasons. If you want to look for economic roots of conflicts, the story could be just that because of the reduction in agricultural output, people who were originally kind of contented with their life, who didn't have hunger problem, now had hunger problems, they will fight each other. So if that's your theory, then your hypothesis would be the economic growth or agricultural output for an agricultural country was caused, the changes in agricultural output is kind of causing reduction in GDP or reduction in output is causing more conflicts. But people could argue that maybe this country was poor if you just compare countries that were rich and poor and look at whether or not, or regions that were rich and poor and whether or not the poor areas have more conflicts. There could be all loads of other reasons, or there could be reverse causality. These places have a lot of conflicts that made it unable to grow. So one idea people have been using is to use rainfall as an instrumental variable for this to study this relationship. So rainfall is going to make an agricultural country more productive. So if you have more rainfalls, your crops grow better, and your crops grow better. If your story goes, people are less likely to fight against each other for limited resources. So the idea is to use variation in rainfall as to explain part of the variation in GDP or part of the variation in agricultural productivity that hopefully are able to explain the part of variation in conflict. That's the idea of constructing instrumental variable. Of course, here the argument should be that rainfall could only affect conflicts through the channel that it affects agricultural output, or that it affects GDP. So it's not like these people were saying that because it's raining, that's just don't fight with each other. You can't have that argument. Another kind of classical paper on instrumental variable is basically the $1 million prize problem in labor economics, is to explain the effects of education on earnings. So can you think of some factors that affect education more exogenously? So it could only affect earnings through affecting education. So it's going to be a factor that affects education, but otherwise, other than its effects on education, it shouldn't be correlated with earnings. So something that could explain education, but not other parts in other parts in the variation in earnings. you think of reasons for that?
Proximity, maybe, to schools surrounding the person.
Yes. So one idea people had is we look at how close these people were to schools. So imagine if the parents are more likely to put the kids at school when there are schools nearby, then the kids that live closer to schools were more likely to get better education. But then it's a matter of faith whether or not you believe the proximity to school only affects earning through education, because there could be people from other camps saying that your home location choice is endogenous. Maybe the parents that just the houses near schools are more expensive. The parents who could afford to put their kids very close to schools tends to be richer parents.
Class size.
Sorry?
Class size.
Class size. So how would class size affect schooling?
The quality of teaching and learning. That would not
yes.
determine the earnings of the students.
But basically, that's you want to construct some factors that affect the quality of schooling. But you can imagine this is also a choice variable. Like you put your kids into different schools, that there is definitely selection there. The schools with small class size might just be more expensive schools, and only rich parents were able to put their kids into the schools with small class size. Like basically during economic seminars, people just have all these arguments and counter arguments about whether or not an instrumental variable is truly valid. So we call an instrumental variable valid when it's not correlated with unobservables. So another the kind of classical instrumental variable people have used is the quarter of bursts. So the idea is that let me think how it works. So basically, the idea is that I think it's the U.S. regulation where you have to stay in school before 16 years old or whatever cap. So if you drop out of if you want to drop out of school, you have to do this after your 16th birthday. But what matters here is that the year of matriculation, the year you went, the amounts you got admitted to school was kind of fixed in other places. Suppose here, I forgot what details were in the US. Here you had to basically, even for primary schools, you had to enter into the school in September. The classes started in September. So if you were born in August, suppose you're supposed to go to school after 6 years old. If you were born in August, you are more likely to receive education at a younger age than someone who were born in October. You can get this idea. So suppose the kids were sent to primary school after 6 years old. So you have to be at least 6 years old to enter school, and you must stay in the school before the before 16th or 18th, before 16th or 18th birthday. Suppose that was the regulation. Then naturally, kids who who were born in August were more likely to receive slightly longer education, maybe just one year more of education than kids born in October. Because when a kid born in August entering into school, he or she were more likely to be 6 years old plus a month, right? But the kids who were born in October were more likely to be 6 years old plus 11 months when he or she enters into school, and he or she has to stay in the school until 16th. So basically, the kids who enter into school at a younger age receive 1 year more of education. That's their idea of constructing instrument. And I think it's relatively clean in the sense that it's hard to think of reasons why quarter of bursts affects earnings apart from its effects on schooling under this specific regulation, right? Or if you can. But generally, if you trust this idea that the quarter of burst is more or less random. It's not just random because pretty much year of birth is determined by your parents. But you can't imagine that parents trying to time the birth of their kids around schooling year. But there might be, I think. But they are much less of a concern than other types of selections. So that's the rationale of using quarter of burst as a determinant factor of variation in schooling, trying to isolate the part of variation in schooling to explain variation in earnings. Do you trust this story?
What about the school construction? You mean schools that are older, have more tradition, so they're supposed to be more efficient in the teaching skills?
What do you think? Can you repeat this?
School construction instrument related to school in regressor.
School construction would be, suppose there are just new school construction plans in your city. There happen to be just, you can imagine this is somewhat of a definitive idea where after several years, before 2008, there were 2 schools in your region after 2008, there were 10 schools in your region. Kids that were supposed to go to school after 2008 are more likely to receive education than kids who went to school before 2008. And you can do a cohort to cohort comparison. If you believe the construction of schools were kind of more upper level and less likely to correlate with the differences of the outcome of these kids at their individual level. So that's also part of the idea. We try to isolate factors that's not going to be confounders.
Ask about the tuition fees can be used because of the effect of a choice.
Yes. So if there are to use tuition fee changes, to use tuition fee as an instrument variable, first you need to have tuition fee differences across region, right? In some places the tuition fee were uniform, and you need to claim or you need to prove to others, you need to convince others that the variations in tuition fees are not likely to correlate with earning apart from schooling. As you can imagine, maybe richer places they just charge higher tuition fees, and their richer places the kids are expected to earn higher earnings. There are more job opportunities, larger tax base, higher tuition fee or lower tuition fees. So another example is fertility and labor supply. The idea is that if you want to study how the fact that having a having a child affects the career decisions of women, affects women's labor supply. Bear in mind that the choice of the choice of having kids and the choice of working are joint. So when you're deciding whether or not to have a kids, you probably have some mind about your prospects of labor market after having the kids. So maybe the women who are earning, who are motivated, who are more capable, who can get good outcomes in the labor market are less likely to have kids than women who don't expect too much from the labor market. So you can't just regress labor supply or hours of work of women or wage of women on fertility. There are just other factors about these women that's jointly affecting these two decisions. So some instrumental ideas about the kind of randomness of childbearing process. So one idea is that in general, people like to have kids of different sexes. So suppose you had a boy and you had a girl, you stop there, you're satisfied. But if you have 2 boys, maybe you are more likely to have a third kids than a family with a boy and a girl. Or if you have 2 girls, you're more likely to want to do even more demanding of the third kids. So the change of the number of kids from 2 to 3, the kind of likelihood of a woman have a third kids somewhat depends on the gender composition of the first 2 kids. So that's an idea. So if you want to study the effects of having the third kids or the career choice of women, you are able to do that. You're able to use the gender composition of the first 2 kids as an incremental variable. So that's another idea. So of course, you can always raise concerns about using this instrumental variable, such as maybe the gender composition of the 2 kids were not random. Like sometimes there are just so many sex selection, gender selection techniques with childbearing. The women who specifically choose the gender composition of their 2 kids, which is different from other sorts of women. So that's one criticism. And there is a recent paper using Denmark data. So that paper is better in the sense that they're exploiting some type of variation, experimental variation. So they I think in Denmark women could apply for some kind of technical assistance of having kids if they can't have kids naturally, and there is a lottery for that. So they're using this lottery to decide. Basically, if you get the lottery, you're more likely to get to bear kids. So if you're fine with the basic concept of instrumental variable, in our specific example, the idea is that we can use Olympic regulation as an instrumental variable for pollution. Bear with me. So the Olympic regulation, for instrumental, I forgot to mention this. For an instrumental variable, you need 2 conditions. You need to check 2 conditions whether an instrumental variable works. First is relevance. So your instrumental variable, that's called that should the variation in that should be able to explain variation in X. That's what we call relevance. So some criticism against the use of quarter of burst as explanatory variable in schooling is just the explanatory power of quarter of burst on education is just on schooling is just too small. Like imagine you can the change of quarter of burst at most explain less than 1 year of schooling, and you can imagine this correlation might just not be so strong. But here the relevance is more likely to be satisfied. You can check this directly. Here Olympic regulation affecting pollution. The relevance condition could be easily checked using this figure or more well-designed statistical methods. Another condition which is more subtle is about exogeneity. Autoimmune regulation could only affect health other than pollution. This is something that you can't test. It's a matter of belief. So whenever you read these people, you have to be critical about whether or not this condition is fulfilled. So these are their reported results. So I'm going to put a lot of tables, presenting a lot of results from tables. To read these tables, I realize that a lot of you just, unless you're coming from a discipline, have difficulty reading this table. So generally, these reported coefficients are just resulting in obtaining in regressions. The numbers in the brackets were standard errors. The standard errors would just telling you how much confidence should you have on your estimated coefficients. So how statistically significant it is. So as the standard error is small and coefficients are large, it means that you have more trust on that. So the stars are just showing you statistical significance. More stars, let's just say more stars, your results are statistically more trustworthy. So if you don't have any stars, it means that your point estimate is statistically not different from 0. So there is some randomness in this coefficient, and you can't just rule out the hypothesis that your coefficient is different from 0. And usually in the regression tables, these are the explanatory variables, these are the outcome variables. Usually they are done in different specifications. So FE are fixed effects. So I don't want to go too deep into fixed effect, but a city fixed effect would just control for dummy variables of each cities. So city fixed effect are likely to partial out all city level time invariant factors. So all things that don't change at city level, but it gets controlled for. And that's a typical thing you put in the difference in differences specification. I don't need you to explain the type tables, but sometimes you need to know basically this is an active number. It's kind of showing an active relationship between regulation and PM10, and they're statistically significant. That's fine. So this first part of the table is trying to explain an active relationship between regulation and traffic control on pollution, and the second table is trying to show the relationship between PM10 and mortality. Here they're calling this second stage because using the instrumental variable, the first stage is to check how much do regulation and traffic control explain PM10. The second stage is how do regulation and traffic control induced change in PM10 affect health. So the second relationship is between mortality and PM10 concentration, and the PM10 concentration is instrumented by regulation and traffic control. The way to conduct this, if you're interested, you can just take a look at the method papers, the econometric textbooks. But I won't go very deep into that. I'm just trying to give you the basic idea of constructing empirical design, and there are technical details about how to actually carry out a specific empirical design, which is not the focus of this course.
I have one question. I mean,
sure.
Number 1, 2, 3 are 3 different collection of samples, I suppose. We have observation 1,930 for each group, I suppose.
You mean the number of observations?
Yeah, because we have 1, 2, 3 as 3 groups with 3 values regarding regulated. Minus 5.64. Percent, I suppose. I don't know.
Yes, I think the difference between these 3, each of them represents results from one regression, one setting, and the difference is just they add different controls.
Yeah, in this case, temperature and the precipitation.
Yes.
Okay. I was wondering the meaning of the second value, mortality. 0.09. It means 9% of 0.09% of death chances. I don't know. At the specific.
I think it means that when PM10 increases by 10 units, the mortality, since mortality is in log, mortality increases by 9%.
I got it.
So another thing is you would like to check magnitudes. Does it make sense? They can also look at the effects over different types of mortality rates, and it's obvious that the effects are concentrated on CVR. But the effects are basically when you don't see stars, it means the results are not statistically significant. So you can read them as zeros in the statistical sense. So in plain English, it means that you can say that the effects of PM10 on non-CVR mortality rates are close to 0 or ignorable. So this table is just a representation of this figure in numbers. Mortality rate. So I think I already talked about this study design, you can take a look at it to see whether or not it makes sense. So let's have a 7 minutes break at this stage, I think, before let's come into the final empirical method. Any questions up to now? Good. Okay, let's come back. So we talked about two empirical approach to kind of non-experimental empirical approach, differences in instrumental variables. As you can see, some of them sometimes they can be used together, like in the paper I just presented. The difference in differences variation is used, the idea is used to construct instrumental variables. So the final approach is something we call regression discontinuity. Regression discontinuity is the idea that suppose there are arbitrary rules that determine an outcome of some x variables. So suppose in terms of schooling, if your college entrance exam score is higher than 600, you get college education. If your college entrance exam score is 599, you don't get education. You won't be able to get a college education. Suppose there is such a rule. You can imagine it's going to be really nice if you're studying the effects of college on earnings. So you can just collect all the people whose college entrance exam score are 600, 601, 602, and people whose college entrance exam score are 599, 598. And your belief would be that the very small differences in college entrance exams scores performance is just ignorable. Most likely, these two types of people, they have exactly the same IQ. They kind of score very similar score in exams, or there is a sharp difference in their college education. One group of people got college education, one group of people fails to get college education, and you can just trace them into their labor market and look at their earnings. Suppose you can obtain some data like that. That would be the idea for regression discontinuity. You're looking for arbitrary rules, and basically trying to collect observations or individuals around this cutoff and see whether or not you could observe a sharp difference in your outcome. Other examples, students receive a scholarship if their GPA is about 3.5. You can look at students whose GPA were 3.5 versus whose GPA was 3.49, right? Something like that. So these are just an example where American high school students awarded a scholarship on the basis of some test scores. You can imagine regression continuity is used a lot in the education setting because the admission scholarship awarding, a lot of outcomes were based on scores, and there has to be a cutoff for some people to receive it and some people who can't receive it. So all you need to do is try to compare people very close to the cutoffs. So if these people who differs by 1 point in the college entrance exam end up having a very different wage several years later, the only thing you could attribute this wage gap to is the fact that by a little bit of good luck, some of them get education, college education. So this is the idea of using the scholarship cutoff. The fact that a scholarship award depends on some arbitrary cutoff, and look at how scholarship helps students finish in school. So the idea is basically concentrates around finding a sharp cutoff, where above and below this cutoff you have very large difference in specific outcome. In specific outcome in X, in this case it is college education. Sorry, in this case it is scholarship. In the other case, in the college entrance exam case, it is college education. So typically you would like to check for a gap in your outcome. So sometimes we call these X, or we call this college entrance exam score or GPA or this SAT score running variables. So you're trying to identify gaps in a specific outcome. It's called a scholarship or college education. We try to identify gaps in a particular outcome around a particular variable. So these are all examples. Sometimes you don't necessarily have the gap. So in this case, it's not exactly a gap. You need to be careful in identifying the gap. So another application of using regression continuity, I would like you to kind of comment on this paper critically, is to look at is to exploit the a specific type of geographical division in China. So this geographical division is sometimes considered as the division between north and south in China. So usually it's called Qinli Mountain and Huai River. So these parts It's a mountainous area. This part is a river. So in China, there is this specific rule in winter heating where the winter heating is provided at a very low cost and a little bit mandatorily to urban households to the north of Huai River, but to the south of Huai River, there is no central heating, central winter heating provided by the government. If you need heating in winter, you have to do this by yourself. So that's a major difference, and sometimes it's used as a discontinuity. To some extent, you can use this as a discontinuity. And the reason that this division is used to help the study of pollution effects on health is because a large proportion of pollutants in winter in China are attributable to heating. So a lot of these central heating facilities rely on coal burning, which are extremely polluted. And this is one example of this winter heating policy line and PM10 concentration. And hopefully you will be able to observe a discontinuity around this division, around this policy line, where PM10 concentration is much worse to the north, to the north of this river than to the south of this river. And remember, the key point for regression discontinuity is you want to focus on relatively close range cities that are pretty much close to this cutoff. You don't want to compare students scoring 600 to a student scoring 500. You want to find a student scoring 601 to a student scoring 599. Similar idea here. You don't want to compare this city to this city, but you might be able to compare this city to this city. These two cities, their winter level pollution, their winter pollution is more likely to be an outcome of this arbitrary geographical line that decides winter heating policy other than other things. So that's the basic assumption to construct this idea. And this is the concentration of PM10. Usually for regression discontinuity design, you want to show discontinuity in figures in both X and Y. So hopefully you should be able to see a gap around these cutoff for both X and Y. So this is X, the PM10 concentration. As you can see, you move north to the Huai River, you are likely to have a gap, an increase of PM10 just across the river. And this is the health outcome. They're basically using life expectancy. So their results are basically the estimated change in life expectancy just north of the Huai River. So if you move from city adjacent to Huai River to the south to a city adjacent to Huai River to north, people on average live 3 years less, and it's statistically significant. And basically, you can convert this to how variation in pollution affects health or life expectancy using basically north of Huai River as an instrument for pollution, right? That's what the instrumental variable is about. If you want to review the relationship between pollution and health, you use Huai River as an instrument, like to locate in the north of Huai River as an instrument for winter pollution level. And the assumption is then the fact that you are in the north of Huai River should only affect, you're slightly on the north of Huai River should only affect your health outcome through pollution. So how do you feel about this? Are you convinced by this design?
From the mapping, page 55, there is a large evidence that in many areas there is a big difference in PM concentrations in most areas. Even though in some areas there is not so much difference. Maybe it's the mountain area, I don't know. Chinese, yeah, that point. Here it's almost
even this part, although it's to the south, it's still pretty polluted.
It's similar to the northern part.
Yeah, I don't know how to explain that. Yeah, maybe there are other reasons. Maybe there are more industrial activities around here. But it's fine. Like they're saying that if there's no difference in X variables, it's not used, and the variation is not used. We are pretty much identifying the differences. Cities where you have differences in X variables to explain differences in Y variables around this area.
I agree. I mean, in some areas in which there is a steep difference,
yes,
this is the main reason. In other cases, it could be there could be some other effects that overlap with the.
Yeah. So the most important factor about regression discontinuity is that you need a sharp gap. You need to see visibly in the figure that there's a sharp jump in your X variable. Otherwise, you could say that if this variable is moving smoothly across the boundary, it means the boundary itself is not explaining anything. It's just the north and south itself is explaining things. It's not the north and south to Huai River that's explaining things. Of course, one idea that I could think about is that basically to have this instrumental variable to work, you need it to affect health outcome only through its effect through pollution, right? But one idea is that winter heating could be affecting health directly, right? If you receive winter heating in winter, you are less likely to die from coldness, right? You're less likely to have diseases associated with exposure to the coldness, right? If that story is true, would the health outcome, would the 3 years less of life expectancy to be an overestimation or an underestimation? So will the effects of pollution on health outcome be overstated or understated? If there is this second channel, basically if you live to the north of Huai River, you are likely to receive winter heating and more pollution. And both of them are going to affect your health outcome. So if both of them are going to affect your health, will the results we obtained, pretending that your health outcome is only dependent on pollution, overstate the effect of pollution on health, or understate the effect of pollution on health?
Would it be understating it? Because at this, it's like you have a negative relationship and a positive relationship, so they're kind of netting out. And then yes. That net is obviously going to be different if the heating wasn't there to, I guess, help people be more healthy.
Yes, indeed. If you believe winter heating helps increase life expectancy to reduce mortality rate, then it's basically saying that winter heating saves 2 years of life. Pollution kills people by 5 years. Pollution shortens your life by 5 years. Added together, it will be 3 years. So the actual effect of pollution on health might just be 5 years. If we ignore the fact that heating itself helps. So that's all for this session. Hopefully, you will be able to enjoy or to understand the beauty of empirical research design. And if you have some idea, as I said, one type of individual project is to write an empirical proposal. So if you have some idea about testing theory, testing economic relationship using data, you're welcome to use your knowledge from this class. The purpose of priming you with empirical approach is that we are going to study empirical evidence around environmental issues. So one area where we use data or we use observations in real life to answer a lot of environmental important questions in environmental economics is about the valuing of environmental goods. Put simply, so remember in the theoretical part, we're interested in the social marginal cost of emission. How do we measure the social marginal cost of emission? Or sometimes when we're talking about protection of natural resources, how do we value the benefits of environmental resources? So they're public goods, right? You don't pay to visit national parks. You don't pay to breathe clean air. So how are we going to say how much clean air or how much national parks are worth? That's the basic questions asked in environmental valuation. So they could be applied in many different settings. For instance, one important area for environmental evaluation is to judge the damage through environmental disasters, such as ExxonMobil. If basically ExxonMobil had a ship that spilled, had oil tanks that spilled a lot of oil into an open sea area around Alaska. Basically, ExxonMobil was facing charges, claims for compensation for basically the damage of the environmental areas, the areas around it. How much does the area worth to surrounding residents or to basically the human race in general is a question. So it's an important question because it pretty much determines how much we want ExxonMobil to pay us, right? And another area to use environmental evaluation is when we decide to allocate funds for environmental protection projects. So how much fund do we need to pay annually for the protection of national parks? So in terms of valuation, the fundamental question is how do we decide where the value of a particular goods come from? So here for environmental goods, sometimes we categorize them into 3 different types of value. One is called use value. So you need to directly interact with this environmental resources, such as fishing, beach visiting. If you know what's the value of a panda protection zone, you visit this panda protection zone every year, and basically your value is coming from your enjoyment of seeing the pandas. Option value is a willingness to pay for the future ability to visit or to use this environmental goods again, because the preservation or on the other side, the destroy of environmental goods sometimes can be permanent. So you want to basically factor in the future cost, the future benefit, the option value. That is, I'm not visiting a panda site, panda protection zone very soon, but I expect myself at least trying to see the pandas once. And for that reason, I want the panda protection zone to exist. We want pandas to be protected. Passive value is something called non-use value. Is that you are not going to visit a panda zone very soon. You're not visiting it very soon. You're not visiting it in the future. You don't plan to visit a panda zone. But the idea that the pandas are protected is valuable to you. So this is something we call non-passive value or non-use value. So all these values added together tells you about the total willingness to pay for a specific type of environmental goods, such as panda protection zone. And there are different valuation methods. They're roughly categorized into two groups. One is called a reviewed preference method. One is called a stated preference method. The reviewed preference method about valuation is that I don't need to ask you how much you like pandas. All I need to do is to observe your behavior. So there is a mapping between your preferences and your behavior. So if we are able to see, observe some of your choices, your behavior, we're able to infer your preferences. For instance, like contrary to reviewed preference, there is something called stated preference. It's pretty easy. You're just asking people how much you are willing to pay for something. Take an example of a panda protection zone. Stated preference is just you go to people, ask how much you're willing to pay for pandas or for protecting pandas. A reviewed preference would be that we can collect data on how many people visit panda protection zone each year, where these people are coming from, to have something to say about their value for pandas. Now, these are the specific methods we will be talking about in the class. The highlighted ones are the evaluation methods that I'm going to cover in the class. There are reviewed preferences and stated preferences. Here, the direct reviewed preferences would be just look at price. I mean, basically, the easiest way to look at the valuation of a certain goods is to look at its market price. Right? If we're talking about market goods, how valuable is an iPad? We just look at its market price. So why the market price tells us about the value of an iPad in the reviewed preference way? Because obviously the price is high and you see people buying it. The fact that we observe people buying it at a specific high price means that their valuation of this good is higher than the market price. Right? And that's what we call reviewed preference. Your choice is telling us about your willingness to pay. We don't need to ask you about how much you like an iPad. If we ask you about how much you like an iPad, it would be a stated preference approach. But if we go to the market, see the fact that you're buying an iPad at a specific price, we are able to at least judge that your reviewed preference, your self willingness to pay for iPad is at least its market price. So the preference of individuals can be reviewed by their purchasing behavior. Whenever there is a market, the market price is going to tell us about at each price how much people are willing to buy these goods. Just tell us about the distribution of willingness to pay among the individuals, right? So basically, the valuation across individuals is what we call demand curve, right? Demand curve traces out for each individual how much they are willing to pay to purchase a particular goods. The obstacle for applying reviewed preference approach by looking at the market price for environmental goods would be that they are non-marketed goods. So it's a similar issue for all the problems we encountered in the first part of the course. There are no markets for environmental goods. There's no market for clean air. There's no market for panda protection. So we have to use indirect approach, design some other approach for these type of reviewed preference valuation. So indirect measures we are employing include travel cost, hedonic pricing, avoidance, behavior avoidance, expenditures. We're trying to go through them one by one. So again, the idea of reviewed preference is that when both bundle A and bundle B are affordable, the reviewed preference is how do your choice tell us about your preference? How do your choices reveal your preferences? If bundle A and bundle B are both affordable, bundle A is chosen. It is reviewed preferred to bundle B. So travel cost methods infer values of recreational resources by determining how much visitors spent getting to a site, and use this information to estimate the demand curve for that site. So to explain this intuitively, the idea is that if you're willing to visit a national park driving thousands of miles, then your willingness to pay for this national park must be higher than your travel cost, must be higher than all the gasolines you used on the roads just to get to that area. So the travel cost methods have been used to value national parks, recreational fish, beaches. So the amount is basically trying to calculate how many people are willing to visit these places and how much these people spend just traveling to these places. The motivation, so this is a very practical method. It's being used a lot, especially in the problem of recreational sites, beaches, protected mountainous areas, something like that. And this approach is actually created or invented out of a serious question, which is the history went like after World War II, the U.S. National Park Service sent letters to economists asking them whether or not you know how much the national parks are worth to the U.S. citizens, and that pretty much determines how much we need to allocate in terms of fiscal resources to this area. And the problem is that it's not a marketed goods. If it's a Disneyland, then we're able to judge how much people value Disneyland, looking at the entrance fee they're willing to pay, how many people are willing to pay this entrance fee. But since we're talking about national parks and they're free, we won't be able to directly look at its market price because there's no market for that. So the travel cost method was actually invented by Hotelling. So you remember Hotelling? He was the guy who predicted about the growth trend of oil prices, or the Hotelling rule told you about basically how would you use non-renewable resources, what was the extraction path of non-renewable resources. That's the other work of Hotelling. So this is another work of Hotelling. It's trying to value national parks. So this was the original letter he wrote to the government guys. Remember, basically, it's the U.S. National Park Service wrote to economists soliciting methods for park valuation. Hotelling wrote the letter that this was the original letter. The idea was that for a pretty remote beach, I'm not sure if you have been to this beach. I have been to this beach. For a specific beach, if you wanted to know how much Hong Kong people live near these areas, enjoy this beach, what he wanted to do, since this beach was free, it was open to the general public. You can't take a look at its entrance fee. What you were doing is you look at something that pretty much acts as an entrance fee to people, which was the travel cost. So suppose in order to reach to the beach, you need first go to Econ, take a bus, walk for 3 hours. And all you need to do is add up the travel cost to get to this beach. So the thing that lies between you and an iPad is the market price of the iPad. The thing that lies between you and the beach is the cost you need to spend, both in terms of time cost and in terms of fare cost, in terms of monetary cost, in order to get there. It's a similar idea. You use the travel cost as a type of cost. So suppose your opportunity cost of time is 80 Hong Kong dollar per hour. You spend, like the round trip, you spend 6 hours on the trip, 4 hours for walking, 2 hours for 2 hours on the bus, plus $50 on the bus. You in general you pay for 530 Hong Kong dollar per trip just to get to the beach on average. I think here you need to walk for 2 hours. That would explain the 4 here. So the round trip costs you 530 Hong Kong dollar. The fact that you're willing to pay for this, you're willing to spend all the time and resources and money just to get to the beach, means that the value that the beach brings to you is higher than 530 Hong Kong dollar. So the way we do this is that suppose there are 4,000 people who visit this beach each year, and each of them basically pays 500, at least 530 on their road, on their trip. The total travel cost would be 2 million per year. And the total valuation of these people, the valuation we can infer from these people, suppose 4,000 is monthly visit, the total value we can infer from these people are at least or at most 2.12 million. So would 2.12 million be an upper bound or a lower bound for the kind of joint valuation? So will the actual valuation of these people be higher or lower than $2.12 million? You can have different reasons. It's actually an open question.
If we consider the cost,
yes, so
cost is fixed.
It must be, the valuation must be higher, right? It must be at least 2.12 million. Yes, obviously, the reviewed preference approach is going to give you a lower bound. It tells you that your willingness to pay for a trip is at least 530. It could be 600, it could be 700. You're willing to do this means that it's higher than 530. So it's going to be a lower bound for that reason. So it's a lower bound because anyone finds it optimal to spend time at, they must receive at least the travel cost. It could be more. So this is a simplified example. The simplification comes from different sources. First, we assume everyone has the same travel cost, right? So an improvement of this approach is that we might be able to collect data on travel costs for different kinds of visitors. Some visitors who live further away incur higher travel cost. Some people who live closer incur lower travel cost. And people who live closer are more likely to visit this area, this beach, more frequently. That's exactly the idea of demand curve, right? When the travel cost is higher, you're less likely to visit this site. So a more generalized approach applying travel cost is to collect information on visits, calculate round trip costs for each zone. So sometimes you just divide areas around the beach into different zones. You're able to collect number of visits originating from each zone. You calculate the round trip cost. You are able to get a table like this. When the travel cost is higher, here the price is more like travel cost. When the travel cost is higher, the quantity reduces. That's the exact idea about a demand curve, like downward sloping demand curve. You are able to run a regression, get an idea of what the shape of this curve look like, right? And once you have the curve, you are able to basically figure out the consumer surplus, right? So here the valuation is pretty much about the summation of consumer surplus. So you're able to figure out a demand curve, and all the areas beneath the demand curve tells you about the aggregation of consumer surplus. Right? Any questions? So, and you can add more variables to the regression if you're interested in how different attributes, different individual characteristics determine the visitation rate, determine your willingness to pay. You want to look at willingness to pay across different subpopulations. There are concerns about travel cost methods. So before going into all this, can you raise your own concerns about travel cost method? How much do you think the travel cost method might be missing some important points? So what would be the limitations of travel cost method? So how would make it hard to apply or hard to explain what it's supposed to be explained?
Like the health condition, or and the ability to speak different languages, like foreign languages.
Why would that matter? Sorry, I'm just trying to ask you why would how well the travel cost method is to approach to help you understand about the valuation. Of course, here in the regressions you can put in different individual characteristics. If this guy is able to speak a foreign language, he's more likely to visit a foreign country, something like that. Sure. So one criticism you could have for travel cost method is that you have to see people visiting these places, right? So it only applies for use value. So if we're talking about option value and non-use value, you don't see people visiting a panda site, but they could still be valuing the existence of panda. The thought that there are some pandas happily living in some places make them happy. If that's the source of valuation, it's not going to be captured by travel cost method because these people never visit the panda site. That's one thing. The other thing, at least the other thing, when I try to think about this cyclone example, would be how much you actually enjoy your trip to the beach, right? Of course, you probably don't enjoy your bus ride that much, but walking in the mountains, your trip between the bus station and the beach in the mountain, but it's in hiking exercises and hiking activities. You might actually have value for hiking itself. You might be able to enjoy the mountain scene, enjoy the clear air in the mountain area. You're able to observe a scenery of the beach throughout the road, throughout the path, and you have valuation for that other than the beach. It's hard to separate out your potential enjoyment, your potential utility derived during the trip, right? You're treating the whole trip as a cost, but it might not be a cost. It might not be a full cost. Of course, you're paying your time, you're paying the bus fee, but your time is used not just for the enjoyment of the beach at the final destination. Your time is used for enjoy the exercise, enjoy the mountain sceneries, something along those lines. There are other points. So what are the right origin zones? So how far away do we need to draw these origin zones to apply this more generalized travel cost method? What is the right functional form? What is the opportunity cost of time measured? So how would you calculate the opportunity cost of time? So how much would 1 hour worth to you? So hourly wage rates is one idea, but some people would say that you are earning wage for only 8 hours of your day, but you have 24 hours per day. You're sleeping 8 hours per day. You have 16 hours disposable time, and it's hard to say that your leisure time either worth zero or worth your hourly wage, right? Sometimes people are using 1/3 or 1/2 of the hourly wage rate as the opportunity cost of time. But there could be a reviewed preference approach as well. So one idea for people to review their opportunity cost of time, especially during travel, is to observe their choices of going through a route that is more expensive but fast versus a route that takes more time but is cheaper. So imagine that in Hong Kong there are 3 tunnels bring you from the islands to our area, and some tunnels are charging a higher fee than other tunnels. Then the fact that you are going through suppose one tunnel charges $5 more than another one, but it saves you 1 hour. It means that your willingness to pay for time, your opportunity cost of time during the trip is at least 50 Hong Kong dollar per hour. So that's a method used pretty commonly to infer in a reviewed preference way about the opportunity cost of time, especially during travel, because you don't want to compare apples to pears. Here we're talking about opportunity cost of travel time. It's best to put this under a travel setting. So how much are you willing to pay to save an hour during your traveling? A related issue is how do we treat multi-purpose trips? That's another issue, right? If you go to the beach, if you go from your home to the beach and then you spend some hours in the seafood restaurants, then going back home, it's hard to say. It's hard to load the travel cost across different purposes, right? You can say we just divide this. Maybe 80% of the reason of this trip is motivation of the trip is the beach. 20% is for the restaurants. But unless these people is going to tell you about this, otherwise it's impossible for you to know, judging from their behavior. And we know that another issue with travel cost method is that you're unable to put values on different site attributes. So if you're interested in the valuation of the whole site, you can use the travel cost method. But if you're interested in specific site attributes, such as the clean air, the clean water, the quality of sand, it's relatively hard to do so. But it's not impossible, because what you can do is, suppose you can find two beaches. One beach has high quality sand, the other beach doesn't have high quality sand. And there are other attributes that are comparable, then you can use travel cost methods to get a valuation of these two sites separately and construct their difference, use the gap in your valuation between these two beaches as the valuation for high quality sands. But in real life, sometimes it's hard to find comparable beaches. So that's one issue. The reason that it matters is because when we're talking about ExxonMobil oil spill compensation, the oil spill is going to destroy part of the site, right? It destroys the water. It doesn't do a lot of, it might affect the biodiversity of the near ocean, but it has limited effects on air quality. That's limited effects on the ground, on the trees, on the scenery. So if we're using travel cost methods to study how valuable people enjoy visiting this area, we might have a trouble kind of isolating out the negatively affected attributes and the attributes that remain intact after the oil spill. All right, any questions, comments? So other than the travel cost method, and question?
Sorry, I missed one thing. The origin zones, you mean by the place where people come from, go to the place of visit? What is right?
Yes, the origin zone is you draw rings around a particular site, and you try to collect. You're kind of assuming that people who come from the same ring has similar travel cost, and you count the number of people whose trips originate from each originating zone. That's the idea. But you can just treat, this is basically trying to treat distance of travel cost in a discrete sense. You can do this continuously. You can just collect everyone's home address and calculate the distance as a continuous measure. So the zone, the origin zone doesn't matter that much. It's not a key issue here.
Okay, thanks.
I think we are at the time of a break, so let's have a 70 minutes break. Maybe see you in 9:05. Okay, let's come back for the final session of this class. A different approach is called what we call hedonic pricing. Hedonic pricing is basically, suppose we could observe the price of something, and the price of this particular goods is dependent on some marketed attributes and some non-marketed attributes. How would we kind of load the impacts of these non-marketed attributes on explaining something's prices? Typically, the good we were talking about is housing. The housing price is used very extensively in understanding some features of neighborhoods. So imagine when you're making the decision of buying a house, some choice is about the quality of the house itself. Other choices rely on where the location of the house and all the other attributes associated with location, right? And typically, when we're talking about hedonic approach or using housing price, but you can use hedonic price. You can look at other prices. Suppose you're interested in how people value fuel economy when buying cars. When buying a car, you look at how differences in fuel economy explain differences in car prices. So in the housing example, so what you care about buying a house, what makes the specific house valuable, some features attached to the house itself, the size, number of bedroom, number of bathroom, how many kitchens, how many whatever. How old this building is. Neighborhood characteristics, right? The school zone is an important one. The crime rates, how safe your neighborhoods are. Accessible characteristics, whether or not it's close to subway stations, that sort of thing. Environmental characteristics such as air pollution, water quality, proximity to landfills. So the task for us is how do we isolate the part of housing attributes, the part of housing price attributable to environmental quality, conditional on all the other factors that would affect housing price, right? So the hedonic property value is basically the hedonic approach relies pretty much on trying to control for all the other factors, trying to hold all the other factors constant and isolate the variation pretty much. The variation in housing price pretty much only driven by the outcome of interest or interest rate, the explanatory variable of interest or interest rate. So suppose we want to estimate the emphatic benefit of the CVU in HKUSD. So suppose the houses are for sale. The ideal thought experiment is we just find two apartments, one with a view to the sea and one without the view to the sea. The other attributes should be the same, like they're in the same block. They have the same number of rooms, same number of bathrooms, same size. The only difference is one apartment has a view to the sea, the other apartment doesn't have a view to the sea. In a similar location, same height. So suppose we're able to find these two apartments and we know the prices of these two apartments. The gap in their price gap should tell us about the valuation, the individual households valuation about proximity to the sea, about the sea view, right? Suppose for each house, people are willing to pay for $10,000 for the sea view, and there are 1,000 houses around with sea view. The kind of valuation of sea view is something like 10 times 2,000, something like that. So as I said, the key empirical task, the empirical question is how do we control for all the other factors as much as possible, right? Now, in trying